Hi everyone, this is the Lesson 7 Extra Practice ECON315 Guided Study Group. So similar to last week, these problems, there's not many, but the first one is a little more mathematical and has some algebra in it, but then the last two are more conceptual questions, so there's not much explaining I can do other than what's on Canvas, but I still think it's important to go over them, and hearing them might help you in your studying rather than just reading them. So I'm going to get started and look at number 1. So it talks about a profit-maximizing monopsonist. So a monopsonist faces a labor supply curve given by LS equals negative 300 plus 0.01 W, where W is the annual salary. So the first question it asks is, what is the lowest salary the firm can pay yet still induce one worker to want to work for the firm? And then what is the lowest salary the firm must pay to induce 2 workers to work for the firm? So going to the whiteboard, as always, I'm going to write out the given information. So they told us that labor supply equals negative 300 plus 0.01 W, where W is the annual salary. So part 1 said, what was the lowest salary the firm can pay to still induce 1 worker to work? So this means that our labor supply needs to be 1 for 1 worker. So all we have to do is plug 1 in for labor and then just set it and find W. So 1 equals negative 300 plus 0.01 W. So 301 equals 0.01 W, and then divide each side by W, and we get a wage of $30,100. So this wage is telling us that this is the lowest amount the firm can set to get 1 person to work for them. And then it also asked for the same thing for 2 workers, so we can do the same exact thing, but now with labor supply equaling 2. So 2 equals negative 300 plus 0.01 W. So now 302 equals 0.01 W. Divide each side by 0.01, and we get 30,200. And that's all of number 1. Pretty straightforward. So then number 2 says, what is the marginal cost to the firm of adding a second worker, given that it must pay all employees the same wage? Is this greater than, less than, or equal to the wage paid to each of the 2 workers? So the marginal cost of adding the second worker, I'm going to label this as 2. Marginal cost of second worker. So if remembering from earlier in the semester, marginal marginal cost is just the additional cost. So hiring a second worker is going to cost them $30,200 to begin with. But then they also need to pay all the workers the same wage. So looking at worker 1, if they were only getting paid $30,100, that now needs to be bumped up to this $30,200. They're also going to be tacking on an extra $100. So this gives us a total marginal cost of $30,300. Again, marginal cost is just an additional cost of adding a worker. So the first cost that they're going to add is their salary, which is $30,200. 30,200. And then if they need to have all the workers at the same level of salary, then they're going to need to bump worker one up from 30,100 to 30,200, which is a difference of $100. So we also have to tack that $100 onto the salary paid to the second worker. So that gives us a total marginal cost of $30,300. And then it asked, is this greater than, less than, or equal to the wage paid to each of the two workers? This is obviously going to be greater than, since $30,300 is greater than $30,200. And that is all of number 2. So then for number 3, in general, the marginal cost of hiring additional labor for this firm is given by marginal wage cost equals 29,000. Oh, wait a second. Okay, sorry. The marginal wage cost of hiring additional labor is given by marginal wage cost equals 29,900 plus 200L. So if the firm's labor demand curve is then given by labor demand equals 398 minus 0.01 W, what is the profit maximizing number of workers the monopsonist should hire? And what is the salary the workers will be paid? So they give us marginal wage cost and labor demand after already having labor supply. So the profit maximization is going to be always where marginal cost equals marginal benefit. But in this case, it's going to be where marginal wage cost equals marginal revenue product. Thinking in labor terms, that's our definition of marginal cost, marginal benefit, what their marginal wage cost is versus their marginal revenue product. So what we can see from this labor demand equation is that the wage is the marginal revenue product in this problem, from what we've learned already. So all we have to do is find an equation where we're solving for marginal wage cost equals marginal revenue product. So we can do that by combining these two. So if we're assuming that these two are going to equal each other, the marginal wage cost and marginal revenue product, what we can do is write labor demand equals 398 minus 0.01, and then instead of W, you can put in the equation for marginal wage cost. So it'd be 29,900 plus 200L. So originally what we've seen, we're doing an equilibrium problem like we've been doing, but instead of setting two equations equal to each other, I think I've talked about it before, each of these equations are have different variables isolated, so you can't set the two equal to each other, but you can instead substitute one into the other. Hopefully this makes sense to you. But instead of, like we've done in equilibrium already, where I set the two equal to each other when like both wages are isolated or labor is isolated, in this case, in the first equation, we see that the wage is isolated, but then in the second equation, labor is isolated, so we can't set them equal. So instead, I just substituted one into the other. And it's still the same idea as an equilibrium problem. So then we can solve this out. So we can get our labor equal to 398 minus 299 minus 2L. So this comes out to, we can add the 2L to both sides to get 3L, and then simplify. Combine these like terms to get 99, divide each side by 3. So we get a profit maximizing labor level of 33 workers. So this 33 workers will maximize their profits, and then to find the salary of the workers, we just plug this into the labor supply curve we were given at the very beginning. Because notice these two equations talk about their marginal revenue product and their marginal wage cost, but that's not what they're getting paid. So we have to use the labor supply equation to find what they're getting paid, because they told us that W was the annual salary in this labor supply equation. So plugging this in, we get, I'm kind of making a mess on the screen. I apologize. I'm going everywhere. So labor supply is 33, so we can do 33 equals negative 300 plus 0.01 W. So 333 equals 0.01 W. Divide each side by 0.01. So we get a salary per worker, the annual salary per worker of $33,300. So hopefully you're able to follow along with that. I know it was a lot and I didn't make my screen very neat, but the big one with the third one is just recognizing that the wage is the marginal revenue product and profit maximization is where marginal wage cost equals marginal revenue product. And then we can use both equations we were given in question 3 to solve for the profit maximizing level of labor, but then we have to plug that into the original supply equation to find the amount they're actually getting paid. Because if you were to plug it back into the original two equations, one of the original two equations, you would just get their value to the firm versus what they're being paid. In this idea of this monopsony, those are two different things. A worker's value versus their wage. So hopefully that clears some possible confusion up for you and you're able to follow along. But that is all of number 1, and the next 2 are just more conceptual, so we can move on to those. So number 2, the hours workers trade-off. So assuming diminishing marginal product of additional workers and diminishing marginal product of additional hours per worker, how would a profit maximizing firm adjust its mix of workers and hours per worker in response to a new user-friendly computer system that reduces training time required by 1/2? So for this first one, if we're looking at it, we can see that this computer system reduces training time, so the hiring process is going to be easier. So because of that, the firm can hire new workers or reduce the number of hours per current worker. That's what the answer on Canvas says, but I think I would lean more towards the part about hiring additional new workers. I guess reducing the number of hours per current worker can be thought of as like the hours of training time would be reduced, but I see it more as since the hiring process is easier, then they can hire new workers. So same question for number 2, what would happen, or how would a profit maximizing firm adjust its mix of workers and hours per worker in response to new legislation requiring workers to be paid 50% extra per hour worked, so time and a half on weekends and after 5 p.m. during the week. So there's 2 different things they could do. They could hire additional workers because more workers would mean less people working after hours and on the weekends. Or they could cut the number of hours per current worker so they could avoid extra pay. So again, this legislation could cause the firm to hire new workers or reduce the number of hours, both in attempts to avoid that extra pay from the legislation. And then finally, how would a profit maximizing firm adjust its mix of workers and hours per worker in response to a wave of new skilled political refugees to the town where the firm is located, thereby raising the marginal productivity of new workers? So this one's a little more straightforward than the other two. The marginal productivity increases, so that would be good for the firm. So that means with the marginal productivity increasing, the output's going to increase, so they're going to hire more workers. And Canvas also mentions hire additional new workers and or reduce the number of hours per current worker. I see it more of the first part of just hiring additional new workers, again, because the marginal productivity increased. So these three were all just conceptual. They all had like around the same answer, but they could be looked at for different reasons based on the prompt. But that's all for number 2. So last one, again, just another conceptual one. Layoffs in pay. So workers who are laid off from their jobs generally receive lower wages once they find new jobs. Fact 1. Moreover, the wage reduction appears to be persistent. For many years, wages are lower than they would have been had the worker kept his or her old job. Fact 2. Moreover, the wage loss differs by the type of job. Relatively unskilled laborers, such as fast food workers or retail clerks, suffered a smaller wage decline than did certain kinds of skilled labor, such as production workers in automobile or airplane manufacturing plants. Fact 3. What key insight explains all 3 of these facts? So looking at these 3 facts, we can see that the worker has an established amount of general human capital, but they've lost all their specific human capital when they are laid off from one company. So again, that's just distinguishing the difference between general human capital and specific human capital. Workers moving from job to job, they're going to lose their specific human capital. So the skills they've learned, specific, that's the only word I can use really, specific to that job, that's why it's called specific human capital. And then general human capital is the skills and training they've learned that can be applied to any job. But again, these 3 facts show us that the worker has an established amount of general human capital, but loses all of their specific human capital once they're laid off from the company. So again, this was just like a really short week, like last week, but that was all the problems for today. First one was more mathematical, and then the last 2 were conceptual, but best of luck with your studying.